All right, you guys, day 2 is all about probability. As you can see from this chart here, probability is always going to be a number between 0 and 1. If the event probability is 0, it will not occur. Obviously, if the probability is 1, the event is going to occur. All right, there's 2 types of probabilities we're going to explore. We have the theoretical probability, which is the typical probability we're going to figure out, and typically what you figure out when you're talking about probability. You also have experimental probability. Experimental probability is based on some sort of trial or simulation. It's based on what happened. The nice thing about experimental probability, as you do more and more trials, it should converge to the actual theoretical probability of the problem. All right, so let's take a look at things. We're rolling a pair of 6-sided dice. As you remember from yesterday, when we have 2 dice and there's 6 options on each, 6 times 6 is 36 total outcomes. You may have remembered that problem from yesterday. I took a picture of the sample space over here so you can see all the outcomes that are possible when you roll 2 dice. So there are in fact 36 different outcomes. All right, what's the probability of rolling a 7? Well, I know the total number of possible outcomes is 36. How many doubles do we have in the set? Well, we have a pair of 1s, 2s, 3s, 4s, 5s, and 6s. There's 6 outcomes out of 36, which means I have a 1 in 6 chance of rolling doubles. Same on the next one. We're looking at a sum of 9. So we want to figure out how we can get a sum of 9. Well, we can have a 3 and a 6, or a 6 and a 3, or a 4 and a 5, and a 5 and a 4. All right. There's 4 outcomes in that situation. As we reduce our fraction, we wind up with 1 in 9 chances. All right. Looking at example 2, we're looking at a standard deck of cards. And then the card is actually replaced. Keyword being replaced, so our probability does not change from time to time we draw a card. In 100 trials, it says a face card is drawn 10 times. What's the probability of drawing a face card again? This time, we're going to base it on the experiment. So we drew a face card 10 times in 100. So normally, there's 12 face cards and 52 cards in a deck. But that's theoretical. We're not looking at that. We're looking at the experimental. So we're going to say 10 out of 100. It wouldn't be 10 out of 101. It's just based on the experiment. We had 10 face cards in 100 trials. So I have a 1 in 10 chance based on that simulation. Part B. Well, how many cards are not face cards in the deck of cards? Well, you have Jack, Queens, and Kings, all of 4 suits. So that's 12 cards, which means there are 40 cards that are not kings or face cards out of a total of 52. 40 out of 52 reduces to 10 out of 13. And that's the theoretical probability. That's based on the deck. It's not based on a simulation at all. If you want to go to this little applet link, you're welcome to. It basically is a spreadsheet kind of thing that shows as you increase the number of trials, your experimental probability converges to the value of your theoretical probability. But you don't need to. But that's the first part of the day, basic probability.